Hello everyone. Here you can see the pin diagram of ADC 0803 0804. So this is basically the pin diagram of 0804. Here you can see it take analog input and give the corresponding output. And in with the help of this timing diagram, we have seen when the conversion started and when the conversion is ended. So start of conversion and end of conversion. These two terms are important in terms of operation. Now next we will discuss about the interfacing of this A to D converter with 8086. Here you can see this is the microprocessor system. Here in our case this microprocessor is 8086 and this is our ADC. Now this input in plus in minus. From here, we give the analog input to this ADC. This is the clock input, and this clock input is connected with the clock output pin of this microprocessor. So, microprocessor have clock output. This is connected with the clock input of this ADC. Now, in microprocessor, there are two pins indicating read and write signal. And in ADC also, there are two pins indicating read and write signal, and both pins are connected. So we have connected read signal of microprocessor with the read signal of ADC, write signal of microprocessor with the write signal of the ADC. Now what next? Here you can see the digital output. ADC convert this analog input to digital output, and digital output is measured at this DB0 to DB7, and this is connected with the microprocessor. So this is connected with the data bus of the microprocessor. Now here INTR signal of ADC is connected with this INT input. The address bus of the microprocessor is connected to the chip select signal of the 804 ADC. So 8086 addresses are decoded by this address decoder, and this address decoder provides chip select signal for this ADC. So this chip select signal is very important in order to enable this ADC. So without making this chip select signal enable, this ADC can be used for the conversion of analog input to digital out. So this is the rough sketch of interfacing of 8086 interfacing with the ADC. Now this can be elaborated with the help of this problem. Here you can see this interfacing diagram. This is the diagram shown to you, and here this ADC is to be interfaced with the 8086 microprocessor, and you have to write an assembly language program that read the converted digital data to the database. So here, first of all, whenever such type of problem is given, we have to analyze the pins at the interface. So here, this is analog input. This is the clock. This is the reference voltage. This is ground. This is the data bus. This is read and write. And this is connected with the input output read and write signal. This is INTR. Now here you can see what is this decoder. This is the address decoder. We have seen in previous slide what we have seen in previous slide. Just me take in previous slide, you have seen that the addresses of microprocessor is given to address decoder, then to chip select. So if we compare this diagram with the interfacing problem given to you, in this you can see these are the addresses of, from here there is microprocessor 8086, and this 8086 address lines are connected with this address decoder, and this address decoder provide two signals, one is by 0 and one is by 2. So by 2 is used for chip select and by 0 is used for the INTR. So how we have the first we have to analyze the circuit, and then we have to find the addresses. So let's proceed. Let me clear. Then now we will go to next slide. So here you can see total address lines are involved, A0 to A7, and in last slide you can see that A7 is connected to G. This is active high input. So here A7, the value of A7 is 1. And here we require Y0 and Y2. So we use this A0 and A1, differentiate this Y0 and Y2. So here you can see A7 is 1, 1, and A1 and A0 is differentiated 0, 0 and 1, 0. So 1, 0, 0, 0, 0, this up to 0, ATH. So this is binary form, and we have converted this binary number to hexadecimal. So we have grouped these 4 bits. So this is 0 and this is 8. So 80H. H. So this is the address to read INTR signal. So you can see in previous slide, here you can see this Y0 is connected to this INTR. So here this is address to read the INTR signal, and the next is 100 here 2. So this is address to read the current. So in this way we have find out the address. Now how to write a program? So for that, first of all we have to give the information to start the conversion. So at what input is given at the INTR? ATH. So we write ATH. So we use out instruction, and we have written in AL ATH in AL register. Then in first we understand this procedure. What we have to do? We have to start the conversion, then read INTR, then check INTR and repeat the process. Here we have used the loop function also. So we will discuss this problem in detail, this program in detail in next video.